Okay, on number 19, and this is our day 2, we're going to factor the expression x squared plus 6x minus 16. So remember, we did a t-chart. So negative 16 and 6. So all the factors of negative 16 are 1 and 16, 2 and 8, and 4 and 4. Because it's negative, we need them to be opposite signs. Because this is a positive 6, we want the bigger number to be positive. So these would all be positives. These would all be negatives. This one, if I add this up, it's going to give me a 17. Aha, this one gives me 6. So these are the factors I want to use. So x minus 2 and x plus 8. Remember, this test is multiple choice, so you could always double distribute. On the next one, number 20, we're going to just cancel the things that are the same on top and bottom. So x plus 2 and x plus 2. So that becomes x plus 2 over x plus 7. On number 21, on your test, this is actually going to be different. So I'm going to strike this through and rewrite it. I'm factoring for you on the test. So that'll already be factored for you. So we're just going to have to go through and decide what cancels. So the x plus 3's cancel, and all I have left is my x plus 7 over x plus 5. On our division one, we do have to do a little bit of work because we have to keep, change, flip. So we keep this, we change this to multiplication, and we flip this fraction. So that looks like 1 over x plus 9 times, and then x plus 2 times x minus 4 all over x minus 4. Then we go through and we just cancel out the things that are alike on top and bottom, and we write what's left, x plus 2 over x plus 9. Okay, on number 23, I am actually going to factor that one for you too. So this is what your problem will look like. And what we need to know is that a rectangle has an area of that expression, and the width is x plus 6. So in order to find the length, remember, an area is length times width, and we know the area, x times x minus 9 times x plus 6. And we know the width, x plus 6, and we want to find the length. So we need to divide both sides by the width. Those would cancel, and so we get x times x minus 9. Notice x times x minus 9 isn't an answer choice, so we will have to distribute that x to get x squared minus 9x, and that would be letter choice A. On number 24, because the denominators are the same, all we have to do is add the numerators and keep the denominators the same. So what that looks like is x minus 4 plus 6 all over 12x squared plus 30x. Negative 4 and positive 6 are friends, so that makes a positive 2. So that would be x plus 2 over 12x squared plus 30x. All right, on number 25, again, the denominators are the same, so all we're going to do is subtract the numerators. But remember, this guy's really in parentheses because a fraction bar is actually a grouping symbol. So this is x minus 6 minus 3x plus 4, and that's all over 3x squared minus 4x minus 15. So we're going to take that negative and distribute it, which is going to give me x minus 6 minus 3x minus 4 all over 3x squared minus 4x minus 15. And then we've got to combine our like terms. So x and negative 3x makes negative 2x. And then our negative 6 and negative 4 make negative 10. And our denominator stays the same, 3x squared minus 4x minus 15. Okay, the next one, we notice the denominators are not the same. So I'm going to multiply 4 by the 3x minus 3, which is this guy. And then I'm going to multiply the 3, or the x plus 6, by the 3, which is this guy. So that's going to look like 4 times 3x minus 3 minus 3 times x plus 6. And then our denominator is going to be 3 times 3x minus 3. Then I'm just going to simplify the numerator. So let's go with orange. So I'm going to distribute that. So I'm going to get 12x minus 12. And I'm going to distribute this. That's going to give me a negative 3x minus 18. And then the denominator, I'm going to leave it factored in case I want to simplify something later. Now I'm going to combine my like terms. 12x minus 3x is going to give me a 9x. And then I'm going to combine negative 12 and negative 18. That's going to give me a negative 30. And that's all divided by our 3 times 3x minus 3. And I notice nothing matches. So it looks like I might need to do a little bit more work. I know that 9 and 30 are both divisible by 3. So I'm going to go ahead and factor out a 3. So off to the side, what that looks like is 9 divided by 3 is 3x, and 30 divided by 3 is 10. So if I were to redistribute that, I would still get what I started with, and then 3 times 3x minus 3. Those cancel, and it looks a little closer now. And if I want it to be exact, I can take a 3 out of the denominator. Okay, now we're getting into Desmos. You can type any of these into Desmos. You can type them in either all the way, and it may or may not give you that click button to click on, or you can also type them in as 2 separate equations. So you could do y equals x minus 1 over 3x minus 2 over 3x, and then y equals 2x minus 1 over 3x, and find where they intersect. So that is always an option. So if you're ever stuck, you can always do that. So I'm going to go ahead and type that in for you, and I'll paste it in here so you can see. Okay, so this is what it looks like if I put it in the graph. And you see here it's got an intersection point of -2, and I have an a of -2. So if you don't want to do it through Desmos, or if that seems a little tricky, you can always do it by hand. So I'm going to show that to you now. I will have to delete my little Desmos picture here in order to have room to do that. So what that would look like is x minus 1 minus 2 equals 2x minus 1. Since the denominators are all the same, we can just make the numerators equal. So that would be x minus 3 equals 2x minus 1. I just combined these like terms. Then I can add 3 to both sides. So that gives me x is equal to 2x plus 2 minus 2x from both sides. So I get negative x is equal to positive 2 divided by a negative 1. And hey, look at that. I get the same answer that I got if I just graphed it. So whichever way works best for you. You can also get to this point right here and just put that in the calculator. So if you put that in the calculator, it will give you a line at -2. Okay, on this one, we've got to do a little bit more work because the denominators are not the same. So I noticed that the 2x is missing an x, so I'm going to multiply by an x. 2x squared has everything, and x is missing a 2x, so I'm going to multiply by 2x. Now the denominator is always 2x squared. So I have 1x over 2x squared minus 1 over 2x squared is equal to 2x over 2x squared. Of course, you could have always started this at the very beginning and just graphed. So y equals 1 over 2x minus 1 over 2x squared, and y equals 1 over x. And graphed it the same way we did the other one. Let me do that real quick for you, and then I will show you that. Okay, so if I graph it, this is what it looks like, and I can see that, ta-da, a equals -1. If you don't want to do all that other stuff, just graph it. Just put it in left-hand side, y equals, right-hand side, y equals, and see where they intersect. Here's my intersection point. If you do like doing it by hand, we do have to make the denominators the same, so we would do all that multiplication. So again, that was multiply this guy by an x nothing on that one, and this one by a 2x. Once I do that, I get that all the denominators are the same and the numerators can be equal. So 1x minus 1 equals 2x. So I'd subtract 1x from both sides to combine like terms, and negative 1 is equal to x. So I get the same answer either way. The last one here, number 29, is a cross multiplication problem. So I'm going to do x squared is equal to 5 times 20, which is 100. I'm going to take the square root, and x is equal to plus or minus 10. Remember, when we take a square root, we get a positive and a negative. Again, if you don't like that, go for it and graph it. Y equals x over 5, y equals 20 over x, and find where they intersect.